In this video, we will understand writing and executing an assembly language program. The assembly language program is actually a program in which a sequence of instructions will be written to tell a computer to perform specific function. So whatever instructions we are using in the program will be selected from the given instruction set of a particular microprocessor. So what are the steps we have to follow? So we will start with the given problem analysis. Based on that, write an algorithm and then draw the flowchart. Next step is writing the assembly language program by translating each block of flowchart. Once flowchart prepared, then write the instructions in the mnemonics obtained from the instruction set supplied by the manufacturer. For each mnemonic, find the hexadecimal machine code by searching through the set of instructions. Next is enter the program in the user memory in a sequential order by using hex keyboard, and then execute the program by pressing the execute key. So at the end, the answer will be displayed by the LEDs. So all these steps we will see in detail by considering one example. So before going to the example, whatever the steps I said here, just see in terms of block diagram. Block diagram, you see note chart, then it will convert into the mnemonics, and then by manual lookup of each mnemonic convert into the hex code, and then monitor the program, and then write the binary code, and this binary code will be sent to memory. So let's take the example of adding two hexadecimal numbers. So what are the steps? So as you know, we are talking about the adding of two numbers. That means first we need to get the two numbers. So first we will load the numbers in the register. Then once we have the two numbers, then we will add, and then once the result comes, this result or sum will be displayed at the output port, and then program ends. So same thing we will show in the flowchart. So first we will start the program, then we will load the numbers, whatever numbers we have, then these two numbers will be added, and then we will display the result, and then we will end the program. So you see here how many blocks are there. So each block we will consider one by one, and then we will write the instructions. So one by one we will see the blocks, and then we will convert into the instruction. Like you see here, I am translating the flowchart. So you see what first block was loading the numbers, the register. So as we have two numbers, so we are going to use the two instruction for block 1, MBIA. MBIA means move immediate accumulator with the data 32H, then MBIB with the data 48H, and then block 2 add B is the instruction, means add the content of the B with the register with the accumulator. Then the result is automatically stored in the accumulator, so that result will display at the output port 01H. Next block is halt. Halt means end. So these are the conversion of blocks into the mnemonics. Now then we will convert the assembly language to the hex code. Like first instruction is MBI A 32H. So we will see the manual, we will see the instruction set, and we will write the hex code. So MBI A code is 3E, and the data number is 32. So 2 hex code I am writing here. That means MBI A32H is the 2 byte instruction. 1 byte is for your opcode 3E and second byte is for operand 32. Next instruction is MBI B, 48H. So the corresponding hex code for MBI B is 06, that we will find out from the instruction set, and then the data is 48H. So again this is the 2 byte instruction. Then add B hex code is 80. So you see here this is the 1 byte instruction. So automatically by default the content of B will be added with the content of A. A means accumulator. Next instruction was out 01H. So corresponding out mnemonic, the hex code is D3 and the port address is 01. So again we need 2 hex code, one for the opcode out, it is D3, and 01 is the port address. Next is halt. Halt mnemonic is HLT and the hex code is 76. So here we converted the assembly language to hex code. Next is storing in memory and converting from hex code to binary code. So already we listed the mnemonics in terms of hex code. So to store the program in read-write memory of a single board microcomputer and display the output, we need to know the memory addresses and the output port address. So let's say we are assuming here that we are going to use read-write memory storage starting from 2000. So I am deciding here the starting address of this program is 2000. So before storing the program, we will convert our memory content into the binary. That means each hex code we will convert into the binary number. Like 3E, it is equivalent to 0011. It is corresponding to 3, and 1110 corresponding to E. Similarly, 3, 2, 0011, and it is 0010. 0 means 000, 6 means 0110, 4 means 0100, 8 means 100. Here 8 means 100, 0 means 000, D means 1101, and 3 is 0011. 0 means 000, 1 means 0001, 7 means 011, 0110. So you see here total hex code are 1, 2, 3, 4, 5, 6, 7, 8. That means we need 8 memory locations. So if we are starting from 2000, so we will need total location. So I am writing corresponding to each hex code. So you see here, so for 8 hex code, we need memory address ranging from 2000 to 2007. So for entering the program, we will reset the system by pushing the reset key. And then we will enter the first memory address by using hex keys where the program should be stored. So you know we are using here 2000. So we will enter the 2000 memory address and then enter each machine code by pushing hex keys. And then like first is 3E, so you will first and push the 3 and then E and then press the store key. These steps you will repeat until the machine code 76H and then reset the system. For executing the program, we will tell the microprocessor where the program begins by entering the memory address 2000H. As we assume in our program 2000H, So we will tell the microprocessor 2000H memory location, and then we will push the execute key. So this execute key will actually begin the execution. So as soon as the execution function key is pushed, microprocessor will load the 2000H memory address in the program counter, and the program control transfer from monitor program to our program. So microprocessor will begin to read one machine code at a time, and when it fetches the complete instruction, it executes that instruction. For example, it will fetch the machine code stored in the memory location from 2000 and 2001 and execute the instruction MBIA, 32H. So it will load 32H in the register A. The add instruction will add the two number, and the out instruction will display the answer 7AH at the LED port. It continues to execute instruction until it fetches the halt instruction. Then it will end the program. I hope you understood the writing and execution of the assembly language program. Thank you.